Hello everyone, today I want to talk to you about how China's satellite launches aim to expand rocket carrying capacity by tenfold. Also, the Zhuzhou 3 rocket's maiden flight successfully reached orbit, but its major recovery attempt failed. Now we'll have to see if it can achieve a successful recovery within the next 5 years. SpaceX in the United States has already mastered mature reusable rocket technology, and now China is starting to make strides in this field. On December 3rd, the Zhuzhou 3 Yao-1 liquid oxygen-methane reusable rocket, independently developed and funded by China's commercial aerospace company Nanzhan Aerospace, successfully launched and delivered a satellite into orbit on its maiden flight. However, when the first stage rocket body returned to the ground, the recovery mission was unsuccessful. This launch marked the first time the Zhuzhou 3 attempted a first-stage rocket recovery during an actual orbital launch mission. Although there was an anomaly during the recovery phase and the planned soft landing of the first-stage rocket could not be achieved, this mission is still of great significance, marking a historic breakthrough for China's commercial aerospace sector in the technology of large liquid-fueled reusable rockets. Linjiheng Aerospace stated that this mission carried out a flight test of the first-stage booster rocket's vertical recovery technology. According to flight measurement data, an anomaly occurred after ignition when the first-stage booster rocket began its descent and approached the ground. As a result, the planned soft landing and recovery of the first-stage booster rocket at the recovery site failed, with the rocket landing at the edge of the recovery area. The specific cause is still under investigation. Blue Arrow Aerospace was established in June 2015 and is one of China's earliest private commercial rocket companies. The core technological goal is to develop reusable carrier rockets, mainly referring to the most expensive part, the first-stage booster, which is the bottom section of the rocket. Before Blue Arrow Aerospace, whether it was the previous 8-meter ascent, kilometer-level ascent, or 10-kilometer vertical first-stage booster recovery tests, these were only technical verifications, and the rockets did not undertake the task of launching satellites into orbit. However, this time, it was a full experiment with a satellite actually entering orbit. The satellite was successfully launched into orbit, but the first-stage booster, 3T, failed. If the upcoming Zhuzhou 3 can achieve multi-person first-stage booster recovery, and after verifying the repeated use of the first-stage booster, it will move towards true reusability. In terms of technical approach and future possibilities, Zhuzhou 3 and SpaceX's Falcon 9 rocket are overall quite similar. Both adopt the concept of first-stage booster recovery, and there are certain similarities in their recovery methods as well. Both achieve vertical soft landings by using engine thrust reversal to decelerate during the descent phase. However, there are significant differences between the two in terms of the detailed control algorithms of their propulsion systems and their recovery scenarios. This October, after the Zhuyushan rocket completed propellant loading and static fire tests, it already attracted international attention. There have been evaluations suggesting that the Zhuzhou 3 rocket possesses potentially high-performance indicators, with the possibility of matching or even surpassing some of the metrics of the Falcon 9 rocket. It was further stated that if Zhuzhou 3 is fortunate, it could surpass Falcon 9 within 5 years. The number 5 years is quite intriguing. The Falcon 9 rocket had its maiden flight in 2010, and after countless explosions and continuous improvements during that period, a huge amount of money was invested. Elon Musk once said that the company was almost bankrupt. Finally, 5 years later, on December 21, 2015, they successfully recovered the first stage of the rocket for the first time. Since then, up until October 9th of this year, the launch success rate has reached 99.4%. That is, out of 483 launches, 480 were successful with only 3 failures. Some people ask, why is it that despite the great success of China's space program, when it comes to reusable rockets, this field still lags behind the United States? Actually, behind the technology, there's an issue with the development path. In China, as in most countries, rocket launches are handled entirely by the state. In contrast, the United States allows private companies to contract for national rocket launches. Of course, no one wants to see rockets explode in the sky, so inevitably there's a conservative approach. They want 100% certainty before taking any risks. However, testing reusable rockets is full of uncertainties. When SpaceX was first conducting tests, their rockets kept exploding. As long as Elon Musk saw that each test had made some progress compared to the last, he would celebrate it as a big achievement and call it a success. This trial-and-error spirit of private entrepreneurs is completely different from the approach taken in national launch missions. If we go by Musk standards, the first launch of the Starship rocket, even though it failed during the final stage of recovery, was already considered quite successful for a large rocket equipped with 9 liquid oxygen methane engines and a liftoff thrust of 750 tons. Back then, when China saw that Musk was showing signs of success, they rushed to catch up. Landspace was established in June 2015, which was half a year before the successful recovery of the Falcon 9. Landspace is one of the earliest private rocket companies in China, but when it started, it was already 8 years behind SpaceX. Now they have to catch up quickly, so for the Zhuge 3 rocket, if they can achieve reusability within 5 years of its maiden flight, that would be remarkable. They have already caught up to the record set by the Falcon 9 back in the day. Wang Kefan, the founder of Qilin Aerospace and an expert in the private rocket industry, explained various issues regarding the Zhuge 3's test flight to Mainland Observer. He said that the main focus of this test flight is definitely still on whether reusability can be achieved. This is the key to reducing rocket launch costs and achieving a sustainable business model. He's especially looking forward to the vertical recovery of the first stage booster, because this is a comprehensive test of the gimbal, that is, the rocket's flight attitude control device, on both the engine and the rocket's flight control system. The ultimate goal of successfully recovering rockets is often to create cargo flights in space, continuously sending satellites and other cargo into orbit at low cost. The Zhuge 3 experiment is undoubtedly an important milestone and a necessary hurdle on this path. In addition, he is also paying close attention to the Zhuge 3 first stage booster's 9 liquid oxygen methane engines and its stainless steel shell. Methane burns cleanly and doesn't easily accumulate residue. Moreover, after rockets become reusable, their maintainability and serviceability are greatly improved, making them more cost-effective. The use of a stainless steel shell is also a very economical choice, paving the way for ultimate cost control in future rockets. The construction and launch will validate a technology that has already shown disruptive potential in preliminary tests. Whether we can establish our own low-cost, high-level pathway to space in our country requires continuous experimentation. This launch serves as a comprehensive flying laboratory, and every technology it verifies is paving the way for our nation's commercial spaceflight. If we compare the Zhuge 3 with rocket systems worldwide, Zhuge 3 is a strong new contender in the global field of reusable rockets. Currently, the global spaceflight industry is basically following the trend of pursuing reusability and low costs. Although Blue Origin started later than some other exploration companies, it has already reached the forefront of the world. There are many exploration companies, but Blue Origin's rockets hold a certain leading position and have pioneered a new technological path. The core value of Zhu 13 lies in the fact that, through independent practice, it has successfully completed this technological route and achieved its own innovations in certain areas. Its emergence marks the official entry of China's commercial sector into this core competition for future space access rights. The main structural material of the Zhu Jishan is stainless steel, the same material used by Tan Exploration's giant Starship. This signifies a fundamental shift in the core logic of aerospace. The focus has shifted from pursuing ultimate performance to pursuing excellence throughout the entire life cycle. Stainless steel is indeed heavy, which sacrifices some rocket payload capacity because it is heavier than aerospace-grade aluminum alloys and carbon fiber materials. However, we gain 3 key advantages in return. First, manufacturing costs are greatly reduced. Second, its high-temperature resistance simplifies the thermal protection system. And third, the production cycle is significantly shortened. This trade-off is actually very worthwhile. We are sacrificing some one-time payload capacity in exchange for the fundamental cornerstone of reusability. The Zhuge 3 uses liquid oxygen and methane as fuel. The current technical challenges lie in the stability of high-thrust methane engines, the reliability of multiple ignitions, as well as the matching technologies for cryogenic storage and rapid propellant loading. All of these still need to be validated through actual flight tests. The Zhuge 3 rocket is designed to be reused no fewer than 20 times. In comparison, the first version of the Falcon 9, which achieved its first booster recovery back in 2015, was theoretically only capable of being reused 2 to 3 times. It wasn't until the current 5th version that it could be recovered and reused nearly 30 times. So the Zhuge 3 rocket's design with a reuse count of no less than 20 times actually sets a very high bar. After recovery, the Zhuge 3 can achieve a cost reduction of 80% to 90%. According to Wang Kefan, the core of this figure lies in the fact that, for liquid rockets, the biggest cost is the first stage and its engines. The first stage of the Zhuge 3 is equipped with 9 engines. For expendable rockets, the most expensive part, the first stage, has to be rebuilt every time. But with the Zhuge 3, thanks to its reusability, it's like turning a disposable item into an aircraft that can be used multiple times, one build for 20 uses. This means that the cost of the first stage per launch is spread out by 95%. Plus, with the low cost of liquid oxygen and methane as fuel and the simplicity of maintenance, and considering that the maintenance and refueling costs are also relatively low overall, this allows for an 80 to 90% reduction in costs. Essentially, this transforms aerospace from a custom craft into an industrialized product. It's like turning a disposable airplane into a cargo flight. At the same time, the design of the expendable rocket body can also significantly reduce the manufacturing cost per launch. Even if the baseline cost increases from a comprehensive commercial perspective, it's still worthwhile. The satellite launch market is enormous. Huang Keifan said that, looking at the market prospects, the current gap between supply and demand for satellite launches in China is on the order of magnitude. At present, China's annual satellite launch capacity is only about 200 tons, but to meet the networking needs of low-orbit satellites, it is estimated that the requirement is between 1,500 and 2,000 tons. The current capacity is only 1/10 of the demand, leaving a huge shortfall. Therefore, what is most urgently needed are large, reusable rockets like the Zhuzhuo 3. These are undoubtedly the main carriers for low-orbit broadband communication satellite constellations, such as Shengwang and Qianfan constellations. The individual satellites in these constellations are very heavy, and there is a need to deploy tens of thousands of satellites in a short period of time, creating an urgent and rigid demand for high-density, low-cost launch services. At present, once reusable rocket technology is successfully developed, it will significantly reduce the cost of launching satellites and greatly increase launch capacity. As for launch frequency, just consider the 6 commercial launch pads at Hainan Wenchang. They can collectively launch a rocket every 3 days. To sum up simply, China is rapidly catching up in reusable rocket technology.